My name is Jesse Glick. I work at CloudBees. I've been at CloudBees for, a little over 4 years now, working on different parts of Jenkins. But for the past couple of years, I've been pretty heavily focused on pipeline, Jenkins pipeline. So I helped create this feature with Kosuke, and I've been the principal maintainer of sort of the core parts of pipeline since then. So I've seen a bunch of the changes that have gone into it. And today I'd like to talk about some of the things that have come up in the past year, things that we've changed that you might not have heard about or might not have come up in different announcements, and show you a demo of some of these things working together, especially some things that got released quite recently. So just to recap things that changed since I gave a talk at Jenkins User Conference West just about a year ago, very close to here. Workflow was renamed to pipeline, so if you don't know what I'm talking about, then that's great. If you have been using it for more than a year, you would have noticed this change. We were trying to better capture the key use cases that people were looking for in terms of continuous delivery and orchestrating things like this. The biggest change is just that Jenkins 2 now has a new setup wizard that that does some important things in terms of guiding you to set up security, but it also has a much improved way of getting you a reasonable set of plugins out of the box, so you don't have to go and hunt down 24 different plugins just to get some common stuff working. And pipeline is now included in that set of plugins, and so some pipeline-derived features are also in there, so that if you run Jenkins 2 on a new box, as soon as you start it up and you get your admin password ready, you'll be able to begin defining these things and get running. It's also something that we're working on documenting better on the new Jenkins website, jenkins.io. So. Three big components have appeared since last year. So one is the stage view, which provides a visualization of different portions of a pipeline build. That was formerly a CloudBees proprietary feature, and that got moved into open source because we heard so much feedback that pretty much everyone wanted to use this. And you've surely seen announcements of beta of Blue Ocean UI, which is an alternate and newer visualization for key developer-focused dashboards and features in Jenkins, and that's driven heavily off of pipelines. Another thing, which I think was mentioned in the keynote, but there's a talk on it later this afternoon by Andrew Baer, is something called Declarative Pipeline, and that just went into beta, so we're interested in having people try that out. Maybe a big change is that I'm not trying to say what pipeline is, so I hope a lot of you have at least gotten a chance to play with it some, or at least seen some demos that are using it in other contexts to accomplish something. So I'd like to take the time to focus on some things beyond the basics of what it can do that have been added. One nagging point with pipeline was that, of the 1,000-something Jenkins plugins that have been written over the years, most of them were written before pipeline came about, and so a lot of them were designed in ways that really tied them to the fixed execution model of traditional Jenkins projects. And so many of those plugins require some kind of update to be usable from a pipeline context. The good news is that there has been a lot of movement in this, especially over the past year. I have a list of different kinds of Jenkins extensions or feature areas that that require pipeline compatibility. We've been seeing many more of these changes coming in from the plugin maintainers. So people are taking an interest in having this work and putting in the changes required for it. There are still gaps. So I think over time we'll see the set of things that are not yet compatible start to shrink, and you'll be able to do most of the important stuff out of the box. More interesting to me is larger features that are being created that are, like I say, pipeline native. So features that would just be too clumsy to design and show to a user with a traditional GUI-based job configuration. So we had a lightning talk yesterday about external Workspace Manager plugin that tries to solve a long-standing problem that some people have when they have enormous workspaces with, especially people who are keeping a source tree that they're building, say, with Make or something with 12 gigabytes of data, and they want to carry it across from different long-running parts of a build pipeline. That's always been hard in Jenkins. This new plugin makes it easier to manage, and the way that you configure it is with a set of pipeline steps that you can chain together at the right times in your job. We've also seen some dedicated features coming in for deployment and other kinds of management of artifacts with Nexus and Artifactory repository managers. Integration with systems like Kubernetes. There's a neat plugin that lets you set up Kubernetes pods that do little chunks of work that are integrated into your development cycle on a scalable system where you can separate out a little build container that runs in semi-isolation between each part of your build. And specialized integration with Perforce, SCM, things like this. So this is nice to see that it's being used more as a foundation for other features that are driven by things people need to do. In terms of core pipeline, so a pipeline script is basically a program that you run at its basis. It's something that you use to script what Jenkins is going to do in different orders. And so we've added some more things to make that easier to manage. Probably the biggest feature here is replay, which I can show during a demo. And there are some other sort of smaller changes that make it easier to deal with running builds. Something that will be pretty visible when you're writing script is that we now have a simplified syntax available for a lot of plugins, or some of them have been updated to enable the syntax so far, and I think there will be plenty more to come. So whereas until a month or so ago, you had to write this sort of long, clunky set of code here to run the JUnit plugin in pipeline compatible mode. That's been sort of stripped down to just JUnit and then the name of the test results that you have to publish. So some other plugins will be getting that update as well. The larger change is what we're calling Declarative Pipeline. You can see a beta in the Update Center. It'll be under pipeline model definition. This is just a teaser. I don't want to spend too much time on it because Andrew will do a good job later today. But this, you can tell I'm not very good with presentation software. I couldn't actually get this to format. But this long one-liner here, it's really not that long when you look at the fact that it's setting up a pipeline that's going to build in a particular Docker image for a totally controlled build environment, run a build step that you specify, and then regardless of the build result, going to archive JUnit results. So, and it's intentionally doesn't look as much like a program. It's more focused on the key things that most projects need to do most of the time, and making that in a pretty fixed format. We've made some changes to both the documentation and the user interface, especially with the editing of pipeline scripts in your browser and the interactive help on the Jenkins.io website that you get for what kinds of things you can put into your script. There have been some incremental improvements for pipeline as code. So this is the group of features that allows you to automatically create pipeline projects from a repository or an entire organization, for example, a GitHub account, and automatically derive a whole set of pipeline jobs and builds from information in that source control, so that you have very little configuration in Jenkins itself. We'll sort of show this very implicitly during a demo, but we've had some new features that people have requested for finer grain control there. So incremental improvements in Docker support, which we'll be using during a demo. Probably the largest single feature, it's just landed about a week or two ago now, is support for a new feature for loading in libraries to your script. So we're getting a lot of feedback that people were starting to build more and more complex systems, and they want to be able to reuse chunks of definition of how their pipelines work across different kinds of jobs. Because part of the appeal of having your job definition as a script is that you can factor out the common parts of it and put it into a library that other people can then reuse for a lot of different projects. And we had a couple of ways of doing this before, but they all had certain limitations that you'd get in one mode that you could solve in another mode, but that would introduce other limitations. So we've tried to consolidate this into a unified library system, which I'll show how that works in a few minutes. And some other new things that you can do in pipeline script in terms of particular steps you can run. The one thing that's probably going to be visible is that the stage step, which marks different parts of a pipeline, now can take a block, and so they can show structure of a pipeline with different nesting portions. The visualization for this is still a work in progress, but you can at least record that information now in a pipeline where you couldn't before. And so be able to see what this looks like. So one of the features of the old stage step was a way of controlling which parts of the build ran in which order. If you had a multi-stage pipeline and say a last stage was deploying to production, and you wanted to make sure that only approved builds got to that point, and that builds would run in the correct order at that point. These have now been pulled out into separate features that you can mix in sort of a la carte when you need them. The most commonly used one is going to be lock. This is from the Lockable Resources Manager plugin, and now is pipeline integration. So lock step allows you to say that this particular portion of your pipeline build needs to lock some resource that other builds might be waiting for. So this is a very flexible system for setting up synchronization on something. So if you have one possible use, for example, if you have a particular test environment that only can support one test process running at a time, but you have a lot of builds and even different projects that are all trying to compete for that, you can just put a lock around that section and be sure that it's only going to be used one at a time. return standard out option for shell steps was a very commonly requested feature, and we got that in. And ability to look at the change log for your own build sometimes was something that would come up in a bunch of different contexts. If any of you are cloud-based Jenkins platform customers, there are certain major new things that happened in the pipeline integration. I'm not going to go into it here. You should come by the CloudBees booth if you're interested. The most important one by far is a new system for pipeline as code that does not require a Jenkins file in the repository. This is especially intended for cases where you want to insulate developers from anything Jenkins specific at all. So let's switch to a demo so we can see some of these things in action. And please do shout out interruptions. I would love to take questions in the middle of all this. It's no problem. So is this font size readable by people in the back? Is I can make this a little bit bigger. A little bit bigger? Oh, it's good? OK, great. So here I have configured a simple multi-branch pipeline. So what this, you can see the label here even in the UI. So what this means is it's actually a folder that can have several jobs in it that get created automatically for different branches in my source code repository. So this is what get that a little bit bigger. So this is what the Git repository looks like. This would be the root of the repository. In this case, I have some little toy Maven project with some tests and so on, and a Jenkins file. This is the pipeline script that controls how Jenkins is going to build it. And you'll see that it goes through a couple of stages. It gets some source code, and then it goes through a testing stage. And what I'm going to do here is use this library marker at the top of the script that says I want to pull in a definition of a shared library that I might be able to reuse across a whole bunch of different projects. And that's going to take care of a bunch of the details of running things in parallel. So what this project is going to do, here we'll schedule a build for it, and let's see it start running. So if you go to the first build of the project, build number 1, it just went ahead and it got some source code, and then it got a node that a Jenkins agent that it could run some build steps on, and it started up a Docker container to provide an isolated build environment so that we know exactly what kind of commands that we're running at any given point. We don't have to worry about weird tools or libraries or environment variables being set to the wrong thing. And then it goes and it starts running these tests. And in this case, we have I think 100 or so test cases, and it takes a while to run all of them. So it's running through all of these, and each one takes a few seconds. And this is kind of slowing down our development cycle because we're waiting for this long string of tests to run on a single machine, which took there we go, 2.5 minutes to run all of those things. But it worked. But in subsequent builds, what's going to happen is, get a full log here. In subsequent builds, it's going to go and it starts up again. It gets some files, and then it says split tests. This is a step provided by a plugin with pipeline integration called Parallel Test Executor plugin. Doesn't get advertised probably as much as it should. It's a really neat plugin that lets you divide up workloads for testing so that you can take advantage of lots of parallel hardware. You can spin up a dozen machines in Amazon cloud and do all of your stuff in parallel. So, yeah?
How are the binaries that are presumably built by this build distributed to the test worker nodes?
Well, so the question was, how are binaries produced by the build distributed to test worker nodes? That's going to depend on the details of what kind of build system you're using and test system. In this case, if you run Maven test with Maven build tool, it kind of likes to just have a source tree and work off of it. And I don't care that much about the compilation. So what I did was I just took all of the source files, which would be the pom.xml on a source tree, and I stashed them. So the stash command saves them temporarily for use later in the build. And then each time on each of the worker nodes, I say unstash, and I pull those files back into a temporary workspace so that I can use them. Other kinds of test systems have a totally different way of working. They may have a totally different repository with test scripts, and they may pull in artifacts from somewhere else, or they may even retrieve artifacts on their own from Nexus or something like that.
Doesn't that mean that you're rebuilding your artifacts?
In this case it does. For this demo, I don't care because the build part is so quick it doesn't matter. But in general, yeah. So if your build itself is it's a 45-minute C++ build, and then it comes up with a binary, and then you want to throw the binary over to a totally separate test harness, then you would stash that binary and carry it over, or pick it up from some external location. Yeah. Good question. So what this is doing is it's going back to a previous build, and it's saying, OK, I already know from a representative recent build how long each of these tests took and what all of the tests were called. So I'm just going to take all of those and toss them into 5 buckets and try and make them about equal size. And the Jenkins plugin does all of that calculation for you. And it comes up with a list of which tests to run in each worker node. And then it goes off and it runs all of these tests on different nodes. By default, currently, all of the output just gets interleaved, which lets you see what happens in which order. It's good for watching it live, but it's not so good if you want to see one thing at a time. So I'm playing with a little change that just lets you show or hide any individual section. So I'm just going to hide the first, second, fourth, and fifth test runs. I'm going to show only the results from the third one.
What happens to the tests that are new or deleted?
Those get tossed into another bucket. Yeah, so under the assumption that you're not usually totally rearranging all of your tests, then it works fine. And it'll just take a little bit longer if you throw in some new tests each time. So this one is going to run just 1/5 of the tests, and so it goes considerably more quickly. And all of these running in parallel lets the total clock time on the build be shorter if you set it up right. So that's the idea of it. Now the reason you might want a library for that is that setting this up can be a little complicated. So in particular, you need to call the split test, and then you need to go through each of the buckets that's computed and say, okay, for each of these buckets, I want to spin up a new node, and in this case, I also want to run stuff inside a Docker container. And then once you've done that, you have to pull out the information about what's in this bucket. You'll just get sort of a text file. Yep.
So the buckets are created just by dividing the number of tests by the number of buckets, or are you looking at how long the tests take to run to create buckets that are going to last, the same time?
Yeah, so the question is how the division into buckets happens, and it looks at the time taken by particular test cases and tries to take those into account. So it's estimating that each bucket is going to take roughly the same amount of time to run based on past performance. So as long as you have a large number of tests and each one can run in isolation, then this works pretty well. So it's going to do all of the mechanics of writing out different configuration files for each worker agent that says what you're supposed to run. And then this is a library file. So this is just the generic implementation of splitting tests. And And it just takes some callbacks here. So run is just what we call a closure, or basically a function that you can call that says, OK, do the work now. Do the run part now. And then finally, we go into a reporting substage for this branch where we say collect JUnit, format results. And this results, this is again just a function argument. So you can say where exactly your particular build step stored all of this stuff. So the Jenkins file then can focus on the parts of this that are really specific to my particular build system and the layout of my project, where my report files are going to go, what tool set I want to use during my build. And here it's saying I want to use this config file provider plugin in Jenkins that lets you, it's a handy little plugin that lets you, no, that's not the screen I wanted to show. I must have, manage files, yeah. So this plugin lets you define some configuration files that everything on the system can use, sort of site-specific configuration. Here it's a Maven settings file that gives repository mirrors. So it lets you specify configuration files, and then we can go on to our actual build step. So we've sort of split up the logic of this script into this Jenkins file, which is focused more on the stuff particular to this Maven build and where its sources are, versus a library that takes care of the mechanics of running stuff in parallel generally. So, and another nice aspect of this is that if I just say I want to use this library with no other qualifications, that's going to pick up some configured version of the library. So here in this case, I've configured the library at a folder level. So as part of this configuration, this pipeline as code folder, I've added a definition of what libraries I want to make available to my scripts. So in this case, I just give an identifying name to the library, and I say how I want to check it out. So you can retrieve it from version control system of your choice. By the way, there's a pending change for the Git plugin, which I hope to have released pretty soon, which would have it show up under the first option, modern SCM, and that gives you a little bit more form validations and some other features. But in this case, you just say, where is the library located? And you can give a default version to retrieve it from. So master branch in Git is just the trunk, the most recent available version of the library. But if I wanted to select a different version of the library to use in this particular job, I could give a git tag or even a commit hash or something like that. So I'm in control of, I can either choose to always use the latest and greatest version of the library, or I can be more conservative and test out changes to the library piece by piece. Yep.
What would be really awesome is if the string could have the git URL.
OK. So
when the Jenkins file is complete itself.
Yeah, so the question is, can this string have a git URL in it? Yeah, in @library. And yes, there is actually another option you can use. Instead of defining the library in Jenkins at all, there's a way that you can have libraries be looked up on the fly. And so far, I've built a version that uses GitHub. So if you put a pipeline library up on your account on GitHub, github.com/bob/mypipeline_stuff, then anyone who's using pipeline can go and say @library github.com/bob/mypipeline_stuff and begin using your library, and there's no configuration in Jenkins at all. It'll just come from the master branch unless you choose something else. So, yeah. I don't have a name for the feature yet. And that is an extension point, so we hope to see some other ways of defining libraries implicitly in the future too. It's really easy to add them. There's a couple other things you can do. You can prevent people from picking a different version if you really want to lock it down as a Jenkins admin. You can also, if you click load implicitly, then people don't even have to have this in their script at all. It's just going to appear as if it were a built-in function in Jenkins. So this is almost like, to a user, you wouldn't really know that this wasn't just coming from some plugin that somebody installed. It would just show up there. These are folder scope libraries. You can also go to Manage Jenkins Configure System. You can, whoops, it's right here. You can use the same configuration system at a global level. So this would apply to any pipeline script running on your Jenkins system. And and something you can do with the global pipeline library is that these run in a special trusted mode. So if you're using pipeline a lot, you're probably aware that normally the scripts that you run in your Jenkins file are run under strict security controls. So they're allowed to do just kind of plain computation and run predefined steps and things like that. But they're not allowed to make any other kinds of calls into Java or into Jenkins or something like that to make sure that they don't do anything harmful to the system. If you have a global pipeline library, that runs as trusted. So this has been signed off by the Jenkins administrator as, yeah, I know who's doing these and I trust them. So global libraries do not run under sandbox restrictions. And one of the things that you can do when you're running in global libraries, you can use a @Krab annotation, which is a groovy feature. And what this does is you can take any Java library that is present in, it's called Maven Central, which is sort of the global clearinghouse of every imaginable chunk of useful functionality for Java. And you just say @Krab, and you give the coordinates, the name of that library. And then that library becomes available within your global library. You can import classes from it, call things on it, and so on. So this provides a way for you to create a trusted library that picks up some kind of third-party thing. Someone was working on a semantic versioning wrapper, so it's just a little library that does some calculations about what version numbers are considered compatible versus incompatible for a software project. And they're trying to provide a high-level wrapper for it that would be comfortable for use from pipeline script. So if they do that, basically they've created something that feels a lot like a custom Jenkins plugin, but they haven't touched anything except a 20-line groovy script or something that they put into GitHub, and you can start using it. Pretty low overhead. So yeah.
Is there a way to?
So the question was whether @Krab can pull from a private Maven repo. I believe so, but I have not tested it. It's supposed to be a feature of the Krab system, but yeah. So the question was whether, if you're defining classes in your library, which you can do, you can define type hierarchies just like you could in a Java program, and call methods on them and do all of that just like a full API. Depending on exactly how you're using them, you may have to mark those classes as serializable. If it's a good idea to do that because it allows you to use them from parts of a pipeline script that may be long running, so it may actually come back up after Jenkins has been restarted in the middle of a build. There are also other cases where you can do a bunch of work with some sort of internal API that you do it quickly and it's done, and you pass some sort of high-level result back to a pipeline script. For those cases, you would wrap the whole chunk of work that you're doing in an annotation called .non-CPS. I would like to provide an easier to remember syntax for it. I'm thinking of trying to use the native keyword make that clearer. But so yes, right. So the question is whether the libraries can be made locally available or if it calls into version control for each build. Currently, it does try to retrieve the specified version of the library each time you use it from a build. It's possible we could, and definitely that's necessary if you're using something like master, a branch, to indicate the version of the library. Possibly you could optimize it so that if your jobs are using a pinned version, like a git tag or a particular commit hash or a subversion revision number, et cetera, that if it knows it's using a fixed version, it could probably optimize that away and try to reuse the same sources. But yeah, for now, essentially, it's assuming that your SCM is responsive enough that the same way as you would do a checkout during a build of your main project sources, this would be another one. So let's see, that was global configuration. So I'd just like to show that this was completed. I'd just like to show a feature that I guess it's fairly important, I think, but a lot of people don't realize is there, which is this replay link next to every pipeline build. What this does is lets you retry a build from scratch, but after making some changes to what it does. So the use case here is that something didn't go quite the way you wanted. You want to try to tune exactly how the build is proceeding, but you don't want to go and have to make a fresh commit into version control just to kick off a new build and then go back and quickly try to delete it or comment it out before somebody else hits it. So this lets you do sort of prototype changes to how your build works on a case-by-case basis. So let's say I'm playing around with this. I'm not sure, is 5 buckets really the right level of parallelism? You know, what if I choose 10 buckets? Does that change something? So here I'm testing out a change to my main script, my Jenkins file. But if you're using libraries, you also see the option to test out changes to your libraries too at the same time. So and remember this library might not even be something I'm in control of. This might be something that I found on GitHub that someone else maintains. I'm not going to go and fork it or try to get them to put in my untested change to it yet. I just want to see what would happen if I were to do it a little bit differently. So let's say I don't like the name of that stage. I want to call it test part something instead of test section something. So that's a pretty easy change to do. And if I click run, then there we go. You should see it start to run here. So it's going to go through just little preparation stages. Let's just take a moment. And then once it gets to this part, then now you can see that it's dividing into 10 buckets instead of 5 buckets like it did in the previous build. All right, so this way we can test to see whether that was a wise choice or not. And at the same time, it's also, you should see that the stage it's using is showing up as test part instead of test section. So you can play with how that looks in a visualization once we update them to use a more fine-grained level of stages. So if you're satisfied with the result, you can go and click on the diff that comes in the build index page, and then you'll see a standard Unix-style patch format list of the changes that you made since the last since the last regular checked-in version of all of your stuff. So at the top, you see the changes that you made to your project, and down here you see the changes that were made to test in parallel.groovy, to this file in a different repository. Okay. So if you can look over those changes, I could replay this again and make some further edits. It would show me all of the changes that I've made since that first official build number 3. And if I like some of these, I can just copy and paste this into a patch file and actually apply it to my repository and commit it and make it permanent if I want to. And it's important to note that when you're doing a replay, Jenkins keeps track of some information from the previous build so that it tries as hard as it can to make sure that you're rerunning the build from the same set of conditions as far as it can control it. So in particular, this part of the script, let me go back to the Jenkins file. This line, checkout SCM, from a multi-branch project. That's a special syntax that works for multi-branch projects. It means get me my repository sources in the same version of the repository as my Jenkins file itself is in. So I don't have to worry about the configuration of my project sort of sliding out of skew with changes I'm making to my source code. They're always synchronized. And if I replay the build, it's guaranteed that this checkout SCM is still going to be checking out the same version of sources I used in that first build number 3. So I don't have to worry about some other change coming in from another developer messing around with what I'm trying to control for. In addition, when I load a global library from replay, it's going to be using the same version of the global library, even if I was normally pulling it off the master branch for each fresh build. When I replay, it's always going to be taking the version that I ran before. So the question is whether replay selects the same nodes by label. No. Maybe that would be useful. It could also possibly break things pretty badly because those nodes might be legitimately used by something else, and you may or may not care. Currently, it doesn't try to do that. It will control for some things, like it will stashes that you, sorry, not stashes, but build parameters will be copied over from the original one. So if you had a trigger to build with parameters, it'll copy over the same values so you can use them again. So you're trying to do more or less the same thing. So that's this is already finished, yeah. So that's something that's pretty handy for troubleshooting issues and trying to play with other kinds of things. We also have some other things that are useful for sort of managing your build and looking at what it's doing. For example, there's a thread dump link that if you go to that, and it's going to take its time, but let's see if I can make this smaller because it doesn't really work when it's line wrapped. So at the back, you're probably not going to be able to see all of this, but this is basically showing an exact list of what each thread, so each parallel branch in your script is doing, where it's getting that source code from, whether it's from your Jenkins file, or in this case, it's coming from a global library. In some other cases, it's coming from a Docker pipeline plugin, some groovy DSL in there. So you can track exactly what bits of code it's running. This particular thread at the top, it says it's inside a shell step. So it's running a process on some agent, and it will tell you which agent it's running on and what the process ID on that machine of the process is. And this is a temporary directory on that agent that has some control information that Jenkins uses to keep track of the process, even if Jenkins restarts and it loses the connection to the agent. You'll still be able to go back and reattach to it and keep on tailing that log file. So this gives you some more diagnostics you didn't have before. Right, so the question was about, for use from Cloud-Bees Jenkins Enterprise, if this is sort of a more general question, but for Cloud-Bees Jenkins Enterprise, there is a notion of a set of recommended plugin versions that have been tested as a unit. So one thing I sort of breezed over in the introduction was that there's a 2.x version scheme for pipeline plugins, and that allows me to put out emergency bug fixes or new features any day of the week. But if you're on a curated release schedule, then once a month or whatever it is, you're going to get a bundle of approved versions that have all been integration tested. So if I screw up on Tuesday, you're not going to be broken on Wednesday, basically. All right, looks like we're out of time. If you have other questions, please come by CloudBee's booth or the Jenkins community booth, and I'll be in and about for the rest of the day.